Hello all, my name is Konstantinos Costa and I am a visiting research assistant professor at the University of Pittsburgh. I'm very excited today to present EPICGen, an experimental platform for indoor congestion generation and forecasting. The motivation behind this work is to assist with the fight against the novel coronavirus, actually to support mobile contact avoidance navigation applications that rely on indoor congestion forecasting models to effectively recommend paths that minimize the exposure risk to this kind of viruses. Of course, congestion forecasting models need large repositories of historical congestion data in order to train the model and accurately predict the congestion inside the buildings. Unfortunately, we don't have this kind of repositories readily available. So our solution is EPICGen, an experimental platform for indoor congestion generation and forecasting, which implements an efficient algorithm for generating realistic indoor congestion datasets. We have three components: the grid overlayer that converts the floor plans into the building grid layout, which is a specialized data structure that can model the congestion at a high spatial resolution. We have the congestion generator that takes this data structure and some simulation parameters and generate this realistic congestion data. Of course, we wanted an easy way to interact with the system, so we developed EPIC graphical user interface, which is an intuitive map-based interface. So let's see EPICGen in action. You can select each time step independently. So you can explore the congestion every 5 minutes, or you can replay the congestion for the whole day. You can change the parameters of the system. For example, the first one is the grid size. So if you change the grid size, you can get a better accuracy, or you can even change the parameters based on a schedule for the classes. In our demo, we pre-populate the system with the schedule from University of Pittsburgh. You can set up the student arrival time to the class 5 minutes before the class with 1 minute standard deviation. You can do the same thing for the departure. Sometimes some students are not coming to the classes, so we have a possibility of 0.05 for someone not to attend a class, and a walking speed of 1.5 meters per second. Then we can generate the datasets, and then we can use the datasets in an MCAN application. So let's see our own MCAN application, Gabriel Hertis. We are seeing the University of Pittsburgh campus. We want to go from Center Square to Mervis Hall. The idea is that we can choose the accessibility of the path. We can add the starting time, 9 a.m. to 10 a.m. And then we can select the destination building. We have an outdoor distance of 2 minutes. We are tolerating 2 minutes outside and 50% congestion. So the path is going through a building. And if we load the heavy congestion to that specific building, it's going to give us no pass because we cannot satisfy these constraints. And we have two ways to fix that. Either we can say we don't care about the congestion, or we can say we care about the congestion, but we can tolerate a bit more time outside, so we can get a path that has the constraints of the congestion and the constraints of the outdoor exposure. So with this, let me thank you and invite you to join us during our demo session. And if you want to learn more about the project, please visit our website, imsc.usc.edu/EPICGen. Thank you.